Welcome back, MECH 1350. We are looking at Chapter 13 now in our FANUC manual, getting closer and closer to the end here. We want to look at basic under instructions. Okay, we've been working with that in the last chapter. We're going to talk about position registers and miscellaneous different things that we can do, offsets. So let's go ahead and dive right in. So we're going to use our position register, and we're going to, we made those already, so we know that those are global. And you have your safe, your home, your maintenance, all those different positions that you guys made. We're going to be able to apply what we call an offset here, and we got to get into the coordinate systems and understand. So we're taking the position registers we've done before, and now we're able to offset and store an element in there. So we're going to use some other miscellaneous instructions inside a program. So how do we get there? Well, remember when you're writing your program, when you hit next, you can get to instructions or edit commands. So if you're on the main screen, it's point and touch up. You hit next and you get over to instructions and edit commands. Okay, so that's where we can pull in all the different instructions. That's where we did our jump label, we did our if select statements, we did our wait, we did our callouts already. So we've done all those in the last couple of lectures. Now we're moving forward, adding a few more things. So when you choose the register, or the position register in this case, you're going to choose the one that has the I, J, and the next part I'm about to say is the most important part when you do this. So you're going to choose registers, so I'm going to back up a slide just so you know. You're going to hit instructions, you're going to go to registers. Now when you're going to go down to registers, you're going to choose the PR I, J. Now, what happens next is on the other kind of pop out of the screen here under register statement. Notice it chooses R, constant, digital output, digital input, robot input, general output, so on and so forth. Okay? You must choose constant. Okay? If you don't choose constant, it's going to screw up your offset. Okay? So it's very, very imperative that you choose the right piece here. Okay, so let's understand, a little bit about what's going on here. So position register, that's not really changing. Okay, we have the group number 1 to 8. That's still going to be, our robot that we're going to affect there. Okay, and then we're going to change the direction. Okay, so that's the direction, the position register number that we can do. Up to 200 of our PR. All right, so don't get confused with the group number. Okay, for us that's always going to be 1 as we're using this right now. Okay, and then the direction. Okay, the contents of what's in that position register. So those are all the different things that we can affect there. The value that we're going to put in. So we're going to use constant, right? But we're going to change coordinates. Okay, we can always, say that we can store it, our user frame, our tool frame, all those other different things that we've stored in there. We're going to do our operator, so we can do our addition or subtraction, and then by how much, okay, our value. So that's really what's going to happen here. We're taking our position register IJ, okay, and we're storing a value. We're going to do the offset, so we're going to add something to that when we do this, okay? So we're going to take all of these pieces here and put them together. So this is called a position register element. Why? Because we have I and J in this case. All right, the comma will be there just kind of as you see. Okay. So when we go through this, you're going to have your direct, your position register number. Okay. And then your indirect. What are we adjusting? This is important. So if I ask you to adjust X, your J would be a 1. If I asked you to adjust Y, J would be a 2. If I asked you to adjust the Z, J would be a 3. Okay, and if I asked you, yaw, pitch, roll, you guys can see that there now, right? So that would be under coordinates, or Cartesian, if I asked you to adjust X, Y, Z, yaw, pitch, and roll. Or if we were in joint, okay, obviously 1 equals joint 1, 2 equals joint 2, 3 equals joint 3. So if I ask you to offset X, okay, you would have your position register, and then you would choose 1 for the J position. Or if I asked you to offset Z, okay, you would offset make J a 3 there. Hopefully that kind of makes sense as we do this. So where you're seeing this down below is if you look at line 5 in the sample code. Notice how it says PR 1, 2 equals 600. Okay, so we're talking about group 1, okay, position register 1 there, and we are going to offset the Y because the J is a 2, and we're going to offset it 600. So what does that mean to offset something? Well, as it goes through, so say you make your box program, all right, and say we're palletizing something. So what we can do is we can take your box program and then say we want to raise it up 600 millimeters. Well, that's how we would do it. We would just offset the Y 600 millimeters, and it would offset in that direction. Okay, so hopefully that makes a little bit of sense. And we're going to do a couple labs on this so that you understand the offset and how it works. But it's really important on the value that you put in for J, whether you give it a 1, 2, 3, 4, 5, or a 6. Okay? And what the 1, 2, 3, 4, 5, 6 means when we go through this. Okay? So we've stepped into that, and I want you to really understand that, and we'll get through that in a couple labs, and I will be there. Okay? So, you know, just to reiterate, in the sample code here, we got PR1, okay? That's our LPOS, okay? Our left position here, okay? And then when we go over here, we're offsetting the Y, and then we can define that linear movement, okay? How we're going to move that position register 1, what's it starting at, okay? So we can see exactly where those values come from when we control it in the program. Okay? So, if we want to take a look, okay, we have our current robot position. We want to move up, or we want to move the home position. Okay, so that's really what the robot's doing right here as we look through the script on this program. Okay? So, as we go through, you're going to be able to pull out, sorry, we'll step back here 1 second. I just want you to be able to pull out, you know, where the offset occurs. See if you can take a look at the line here, the offset's occurring. Okay? Where do we have an offset? Well, we can look at line 2. Alright, see the PR 10, 3. Okay, and then in line 4 we have 10, 3. So we have an offset that's going on there when we do this. Okay? So, when do we use, we use them in visualization or vision systems. Okay, so we have a vision system on the large robot in the room, and we use it for palletizing. Alright, so think about when you make a pallet of something, or when you buy a case of soda and there's 24 cans in it, and how they stack that in. They do one layer, then the other layer. Okay, so think about that. You guys are going to do some palletizing activities with our stacker blocks in class. Okay? So, we can use an input or a register to set the original value. We can do some mathematical operations, okay? And we want to be able to represent in the point and position registers. We need to make sure that they match. So once again, do everything in world, okay? We're not going to do too much in joint because everything you're programming has been in world, okay? So we have the different offset conditions that we're going to do. Okay, and we can manipulate the position register using the IJ command. Okay, we can also make the register statement here. So notice we're still under register, and notice what we have. We choose register statement, and we have a bunch of series of mathematical operations here. So if you look at line 2, we have 3 dots. Those are what you're going to fill in. Equals 3 dots plus 3 dots. You're going to fill in what the 3 dots are. Alright, with our specified commands that we want to have. And notice we can do multiplication, division, subtraction, all those different setups for the register statement. So that's how we do the mathematical operation. You choose the predefined one. Okay, you're not going to do it yourself. Okay, so then when you do that, Okay, we got to go over 2 menus once you select that. Notice the first menu has register, constant, digital output, digital input, robot output, and general output. Then we want to go all the way over to the next menu and go down to PRI, J. Alright, so that's where we're going to insert that. You'll do the lab. It'll make sense. I will be there by your side, as we go through this. Alright, so timers. Very, very important. You notice we'll do it in PLC class. We've done it in digital electronics. We can use timers to keep track of time, routine, or function. We can override, so we can use a register to set a specified speed. I kind of do that for you when we use the DCS. The DCS, right, that's a master override for speed. So the second that you break out of the cart speed, everything shuts down and says you have a DCS speed error. Alright, but we can also use different registers to control the speed, so you don't have to rewrite and check all the speeds. You can just pull up, hey, the register, whatever the value is in that, that's what's going to run the speed. Okay, we can add remarks. We've already talked about those before, and we can have it display, a message on the screen if we want to. So what you're going to do after this is you're going to go through Lab 20, and you're going to set up a position offset. Now in the manual, there's a procedure that you're going to follow step by step that actually helps you put the I and the J and set everything up and how you're going to do it. And you'll noticeably, I'll do one for you on a video as well, but you'll noticeably see your robot move when you're doing this. So it might do your box program and then raise up a substantial amount, do your box program again, raise up a substantial amount, do your box program again. So we might incorporate the loop equation as well that we did before. So that it'll do it in 5 times and it'll be like us palletizing a case. Alright, and then we can set all that up. I'll go into more detail in a little bit as you're specifically doing the lab, and I'll show you some setups of some palletizing of how I want you to do it. As soon as we got to print some parts though out right now for us to do our palletizing with. But once again, that's the end of this chapter. So you'll go to the end of the chapter, you'll work through Lab 20, and you're going to go through the different offsets and do a small little palletizing program. And like I said, once again, I'll show you a lab video. Alright, if you have any questions, don't hesitate to ask me. And just remember, jog and joint, record in world, alright, and make sure you're in your user frame and your tool frame, and you have the ability now to define that in your program. Alright guys, I'll see you in class or in lab.